Which
like
one?
the fourth question.
Then we okay. Can I see which one?
It's the page before that.
Question 9 is it? Okay, good. Okay. Okay, so question 9. Okay, question 9 is a very practical question. Okay, so you are given a small cutout of a map. Okay, and then in every map you have a, this is called a scale. This is called a scale. Wow, so fat. Okay. So you are given a scale. Okay. Okay. So you need to have a scale. If you don't have a scale, then you can't find out the distance. Okay.
Okay.
So this is the scale. So over here, let me just get the scale out. So it's 0 to 4 kilometer. Okay. So if you have printed that out, right? If you have printed that out, you are supposed to use a ruler. You're supposed to use a ruler, and then you measure the.
It was not printed out.
Oh, actually, you.
No, like that copy, I couldn't
Yeah.
find it.
Okay,
so
never
I
mind.
don't have
So
anything else.
in fact, you had a copy, but you couldn't find it. So.
I measured the screen.
So never mind. So you see that's the thing. You measure the screen here. And you measure that printout. The two measurements. Will they be the same or will they be different?
I feel like it's going to be different.
Yeah. You know why?
Because one is maybe bigger than the other one.
Yeah. And it really depends whether you zoom into this or you zoom out of this. Let me test. So if you zoom in, this, if you zoom in so much, right? This one will be, will be bigger than normal, right? So that's the reason why it's important that you print that one out, so you measure that one. Okay, so I measured yesterday with Nancy. So over here is actually 0.8 cm. Okay.
I measured 1 cm. So
Oh, okay. It's okay. It's okay. I focus on the approach. So if you use 0.8 cm to, so where is 4 kilometer? So this is, so you are given this in a map, which is a scale, and you use your ruler to measure it. It's actually 0.8 cm on the map. So this information actually translates into this statement, which is 0.8 cm on the map. So over here is on the map. I think you can see cm is on the map, right? Then over here is the real life. Does it make sense?
Yeah.
Okay. Then once you have this scale, right? This is the scale. Then now the first question is measure the shortest distance between Bukit Timah to the Botanic Garden on the map. So basically now you need to measure this one. So how much you measure? How much you measure this one?
1 cm.
Yeah. So in fact the scale is actually 0.8 cm to 4 kilometer. But the distance between Botanic Garden to Bukit Timah Nature Reserve, which is here, is actually 1 cm. So Bukit Timah Nature Reserve to the Botanic Garden, this is actually 1 cm on the map, right? So therefore 1 cm is the answer for part A. Okay, they say they want the on the map distance, right? So it's 1 cm. So part B. So part B, they ask the scale of the map in the form of 1 to n. So in a way, right, 1 to n means this one is 0.8 cm to 4 kilometer. So this is the scale. This is scale. By the way, this is the, this statement is for you to find the scale. Why? Because I get it from here, right? So in a way, you need to get 0.8 cm to 4 kilometer. 0.8 cm to 4 kilometer. How do you read this one? 3. How do you read this one? It's 1 to 3, right?
Yeah.
Yeah, so therefore over here is 1 to n. So what is your n, right?
4,000 cm. Wait, no, not 4,000.
Not true.
4,000,000.
Not true. Do you know why?
Why?
Your scale is 0.8 cm to 4 kilometer. Okay? So okay, it depends. What is the measurement here?
1 cm.
Okay, to you is 1 cm. Okay, so never mind if it's 1 cm, then it has to be, if I do it your way, 1 cm. So 1 cm is to 4 kilometer. So in a way, right, for this 1 to n, right, do you know that 1 to n means if you 1 cm to 4 kilometer, you write 1 dot dot 4. Do you think it's correct or not?
No.
Why not?
So, because 1 to 4 shows that maybe 1 cm to 4 cm.
Exactly. So in a way, right, you see, you already understand a little bit of ratio. Okay, actually 1 to n actually is a ratio. So if you write 1 cm to 4 kilometer, this one is the statement. This one is the statement. So this statement, how do you translate it into a ratio format? Oh, so in order to translate into a ratio format, you have to get the 4 kilometer into what you need?
Into cm.
Correct. So this one is in cm. Your this 4 kilometer also must be in cm. Then you can put it into the ratio format. 4 kilometer is
4000.
How many zero?
50.
Yes. So first is 30 to meter first, right?
Yeah.
Then another
Then
20
cm.
to cm. Yes. So if according to your measurement is 1 to 400,000.
Yeah.
So that's the answer. Okay. According to my measurement yesterday, so it's 0.8 cm to 4 kilometer. So now the question is, I have to force, because they force the first one to be 1, right? So I cannot use like 0.8. I also cannot use 0.5. So the question basically is asking 1 to what? Okay? So it's very simple. So this one is 1 cm to how many cm? Okay? So if 0.8 cm is 4 kilometer, then 1 cm is to how many cm? So first you change this to cm first, like you say. So you change it to cm, which is 400,000. So can you see they are both in cm?
Yeah.
So once they are both in cm, then you can use, okay, this is called proportionality. 0.8 cm to 1 cm, there is a factor here. That there is a factor here. You times a factor here, you will get 1 from 0.8. And the factor is, so you just use 1 divided by this will be 0.125. If you check, can you check for me?
Yeah. 0.8 divided by 1 cm, right?
No, it's no. You jump from here to here. So you use the big number divide by the small number. Then you will see that what is that?
It's 1.25.
Oh, okay. Is it 1.25? 1 divided by 0.8.
Yeah.
Oh, okay, good. Thanks. Yep. So you have to follow your calculator. This is 1.25. So if this side is times 1.25 to get 1 cm, so this side also must times 1.25. Yeah.
To get n.
Yes, which is 500,000 if I'm not wrong.
Okay.
Right?
Yeah.
Yeah. So therefore the scale is usually 1 to 500,000 if I use my measurement.
Okay.
Alright? So that solves part B. 1 to n. Okay? Then next, they say find the actual shortest distance between Bukit Timah and Botanic Garden. So if you follow your scale, which is this one, so you measure 1 cm just now, right? So it has to be 400,000 cm, which you don't have to use this one because you already have 1 cm to 4 kilometer. So in a way, over here, find the actual distance 1 cm. According to you, is 1 cm to 4 kilometer, right?
Yeah.
And you also have another scale is 1 cm to 400,000 cm, right?
Yeah.
Then you just ask yourself which one you should use. They say find the actual shortest distance in kilometer. So which one you use?
I didn't answer this question. Because
Now lah, now.
400,000 cm.
But they express it in kilometer.
4 km.
So you should use this scale or you should use this scale.
The first scale.
Yeah, so just use this scale. Then you go and measure the distance between it on the map. On the map is 1 cm. So therefore it has to be 4 kilometer lah. So if I use my scale is 0.8 cm to 4 kilometer. That's the first one. Then the other one is 1 to 500,000. So I'm going to use this one because they want me to express it in kilometer. So therefore I ask myself 1 cm is to how many kilometer? Okay?
Yep.
So the jump from here is times 1.25, right?
Yeah.
So therefore here also must times 1.25, and you should end up with 5 kilometer. You can help me check 4 times 1.25.
5.
Now the last question. The last question is more interesting. The last question is actually, they say the actual area. So we have done with the distance to distance, right? Distance to distance is like length to length. Length to length. That's distance to distance. Distance distance is a parameter of length. Okay? So if I ask you what's the height of you, that is also a parameter of. So basically you see length as an umbrella, the head of the umbrella, then they branch out. They branch out to height of a person, then the length of a table, or the distance walked by somebody. Okay, so length is actually a, what do you call that? It's like an umbrella, then you branch out. Okay, so, or the head of a branch. Okay, so now you have the 1 cm to 4 kilometer, right?
Yeah.
Or you also have, according to your scale, is 1 cm to 400,000 cm. So now the question given is, they say the actual area. The actual area is, so I write it here, actual area. Do you know why the actual area on this side but not this side?
Because that side is the.
Yeah. So this side basically is the
other
map.
area.
Okay. So probably the 2 is a divider. You see the 2 as a divider. Okay. Then the map will be on the left hand side. The map, whatever. The map length is on the left hand side of the divider 2.
Yeah.
Then this one will be for the actual. But over here is the actual length. Okay, over here is the actual length. But they give you the actual area for part D. So the actual area is 1.64 square kilometer. So I just write it down first. 1.64 kilometer, right? Square, right? Okay, good. So now the question is, hey, I only have the length to length, but now they want me to find out what is the map area given the actual area. How?
Oh.
How?
Okay, I do wrongly already.
No, how?
1.64 convert into cm. Cm square.
How can you convert?
1.64 km square convert into cm.
No. No. You are only given the map length to actual length. So in a way, you have the length ratio here. Okay? You have the length ratio, which is 1 cm to 4 kilometer. Then you have to get the area ratio. So given the length ratio, how do you get to area ratio? Is by square the length ratio. Why do you need that? You square the length ratio, that means you square everything here lah. So your 1 is also 1 square, the cm also square, 2, the 4 also square, the kilometer also square. So you get the area ratio, which is 1 cm square to 16 kilometer square. So once you have this, then you can find out what's the question mark. Why? Because the actual area is 1.64 kilometer square, right? You just ask yourself, how do you get to 1.64 kilometer square from 16 kilometer square? You divide, right? Then you will know what is the factor here. You divide by what to get 1.64 from 16?
1.64 divided by 16.
No. If you use the small one to divide by the big one.
16 divided by 1.64.
Yeah. Yes.
It's
Give me a mixed number.
93141.
9
and then
3 over
31.
31.
Yeah. 31
Over
41.
Okay, good. So that how you read this is 9 and 31 over 41. Okay. So therefore your 1 also must divide by this one. So you just use 1 divided by answer, then you will get the question mark.
0.1025.
Okay. So the question mark is 0.1025 cm square. Okay. So to give you a summary of how you should answer this question is, you have the map length to the actual length. Actual length means real life lah. Huh? Okay. For example, it's 1 cm to 2 kilometer. Okay.
Yeah.
Then this is 1 cm to 2 kilometer. Then sometimes the question needs you to get it into 1 to n. So what's the meaning of 1 to n? 1 to n means you have to get it into 1 cm to this one, you get it into
Like
cm as well. So this will be 230 first, then another 20. Okay? So there you get your 1 to 200,000. That's your 1 to n. Okay?
Yeah.
So this is your length ratio. So if you do this kind of question, you have to write down this step. Okay?
Yeah.
Then from the length ratio, right? How do you get the area ratio? You square everything, right? You square everything of the length ratio, right?
Yeah.
Yeah. So if you square everything, 1
1
square, cm square, dot dot,
Oh wait,
2
to square the 1.
you 2. Yeah, square everything. You square the length ratio. The length ratio is this one, this entire thing, right?
Yeah.
So you square everything. So you square the 1, you square the cm square, then the dot dot is dot dot, then you square the 2, and you square the kilometer. I square everything, right? Can you see?
Yeah.
I square everything, right?
Yeah.
So you cannot see, so I square everything. But I put it here. Okay? So once you square everything already, you tidy it up a little bit. 1 square is 1, cm square is cm square, 2 square is 4, kilometer square. Okay?
Yeah.
And usually the question will tell you, hey, what if I measure the actual or the real life area? So sometimes they give you the real life area or actual area, or sometimes they give you the map area. Then they will ask you for the other one. Either they give you this, you get the map. They give you the map, you get the real life. So it's either. Okay? So it depends which one they give you. So let's say they give you the map area, actually is 5 cm square. Then they will ask you what's the real life. I think it's pretty simple. 1 cm square is to 4 kilometer square, right?
Yeah.
Then you just ask yourself, now it's 5 cm square. So what is the proportionality here? Proportionality means 1 person, 2 buns, 2 person, 4 buns, 3 person, 6 buns. That's proportionality. So same thing, 1 to 5, you times a 5, right? So therefore your 4 also must times a 5. Proportionality means this one times 5, this one also must times 5. So therefore the actual area is actually 20 kilometer square in this case. Okay? For just now the case, you still can recall, according to your scale is 1 cm to 4 kilometer, right? Right?
Yeah.
This is the length ratio, okay, by the way. Right? So you need to square it to get, so square means something to the power of 2, right?
Yeah.
To get the area ratio. So therefore you square everything, right?
Yeah.
1 square, cm square, dot dot 4 square, kilometer square. So the simplify it, 1 cm square to 16 kilometer square. And then you were given this is 1.64 kilometer square. Actual. And then you are asked to find the question mark, which is the map. So how do you get to 1.64?
16 divided by 1.6.
Yeah, which is 931 over 41, right? Yeah, you divide by this one, right?
Yeah.
Then therefore, if
then
this side,
one also
yes,
by
this
the
one
same
also
thing.
must divide by the same thing, right? This is proportionality. So therefore, your question mark is 0.1105, 0.102. I cannot recall it.
No. 0.1025.
Okay, so that's how you get. So over here cm square, right? So therefore, that is cm square. Okay?
Okay.
Yeah, so that's how you do such questions. So with this understanding, then probably you can start to do question. I think you can attempt question 13.
I did question 13.
Yeah. Okay, so let's walk through 13 together. Then you can mark yourself also for 13. Okay, so for 13 they say Jewel Changi Airport is made to a scale of 2 cm to 25 meter. So it's 2 cm to 25 meter. So you see they can give you any length parameters. They can give you cm, they can give you meter, they can give you kilometer, they give you mm. So the first thing to do is the height of the world's tallest indoor waterfall rainfall vortex is 40 meter. So find its height in the model. So in a way, right, this is the scale you need to use. This is the scale of the model. Okay?
Yeah.
So now they say the rain vortex is 40 meter. So you put the 40 meter on this side.
Okay.
Yeah. Because 40 meter match with the 25 meter.
Yeah.
It can't, 40 meter can't be here.
Yeah.
Because the 40 meter in the question, that is the real height. The real life height. Okay? So that's why you have to put the 40 meter on the real life side. Like I say, right, the 2 is actually a divider, right? So this one is real life, right?
Yeah, and then the other
That's
one
how
is
it's mapped, right? So that's why I put the 40 meter here, not here.
Okay.
Okay?
Yeah,
So once you put the 40 meter here, then I think the question is, what's question mark? Just ask yourself, how do you get 25 to 40? It's not plus, it's not plus.
25 divided by 40.
Small.
No, 40 divided by
Yes,
25.
yes. Then you get,
1.6.
so it's times 1.6
Yeah.
to get. So therefore you also need to times 1.6. So 2 times 1.6 is actually
3.2
3.2 cm. So that's the first, yeah, so that's the first answer.
I got it correct.
Yes. But did you do it this way? If
Yes.
not, okay. You must do it this way exactly.
Yeah, I did it
Okay,
exactly that
very
way.
good. That's nice. Because if you do it this way, this is a good habit to have. Just do it this way, you will get the answer naturally. You just have to follow. Okay, very very systematic. Okay, the floor area of the model. Aha! Now they give you the floor area of the model is 8. So basically they give you 868.48 cm square. Then they ask you what's the actual in meter square. Okay, so this is actually area to area, right?
Yeah.
So therefore you are given the length ratio here, or you want to look at this, you can look at here, right? This one is the length ratio, right? So from the length ratio, how do you get the area ratio? Because only when you get the area ratio, then you can find out the question mark here, right? So
2 square
Yup.
cm square.
Very good, you square everything
25 square
at meter square. So if you simplify this, you will get 4 cm square to 25 square is 625 meter square. So you just ask yourself, how do you get this to, or okay, you can read from this way, because why? You cannot read from this way this time round, because you are supposed to ask yourself, how do you get to question mark? So therefore you should go from 4 to above. That means how do you get 4 into the 868.48? You times a
times 217.12.
217.12, right?
Yeah.
To get that, right? So similarly you need to get this 625 times the same factor. Then you will get this one. So what's the question?
135700.
Okay. Just nice. Okay, good. So that's the question. Okay?
Yep.
Not rocket science here. We are not talking about rocket science. Very, very simple conversion. Plus, how do you get to area ratio before you can find the actual area? Does it make sense? Okay, so
I worked on this question for I don't know how long, but then I still cannot find the answer.
yeah, of course, because this is the, in fact, this is the gist of this entire concept. Length ratio, area ratio. Okay?
Yep.
Yeah. So next time if you do this kind of question, map to real life, just understand first you have the map length to the actual life length, right?
Yeah.
Once you have that length ratio, you square everything to get the area ratio. Once you have the area ratio, you just use the area ratio to find the map area to the actual area.
Yeah.
Okay? Then the last one, find the floor area of the model if it's made to a scale. So find the floor area. You see, now they change the length ratio. Can you see? They say now the floor area of the model is using this scale, not this scale. Just now we use this scale, right? Just now this is the just now scale. Now they say, hey, I want to use this scale. So okay, it's okay. They give me in this scale, I just do it. So with this scale, which is 1 to 5,000, I hope you know this is 1 cm to 5,000 cm, right?
Yeah.
You need to convert it to 1 cm to meter because you see, it's cm to meter. Okay, so you convert this to meter will be 50 meter, right?
Yeah.
Because you divide by 100, right?
Yeah.
Yeah. So 1 cm to 50 meter, this is length ratio, right? Right?
Yeah.
And they ask for the floor area, right? So floor area, I need to get it into area ratio. So what do you need to do? How do you get to area ratio from the length ratio?
Square everything.
Square everything. Just put the square on top of everything. Then you simplify below 1 cm square to 25,000 meter square. So this is the area ratio. And they say, hey, the floor area of the model is 868.48, so which is 868.48 cm square, right? So what's the actual? Then you just ask yourself, how do you get from 1 to 868.48? Is times 868.48, right? So therefore your this side also must times 868.48. So it's this one times this one, you will get the question. You understand?
Yeah.
Yep. So that's how you can get the area using another scale. Does it make sense?
Yeah.
Okay. So I will say these two questions, they are the hardest. Wow. Oh, you still have 11 actually.
Yeah.
Okay. 11. I hope. Okay. Can you try 11 now? Because now probably you're equipped with the right knowledge.
Can I see the question?
Yes. So let me just zoom in a lot more. Can you see? Is it big enough? Yeah.
Okay.
So please redo question 11 with this new knowledge. Yeah, they are very implicit here for questions. Implicit means not openly expressed. Like Yeah. Like the hidden meaning. They don't want to tell you directly.
Right. No way. It was so hard.
No, it's not hard. It's just that they don't want to tell you directly and make it so simple for you.
Yeah lah.
Yeah. Are you doing C now?
I'm doing A. I just finished A.
Oh. Okay, continue first. Yeah. So sometimes math question can be a comprehension question. Yeah. Yeah. Are you doing C now?
No, I'm trying to figure out how to read it B.
B, right?
Yeah.
So the question given this is, you need to identify 9.4 kilometers square. This is first thing. Is it actual length or actual area?
Sorry?
This is the actual length or actual area?
Actual length.
9.4 kilometers square.
Actual area.
Yeah, so actual area. So you are given the actual area and you are asked to find the map area.
Do I just convert into like cm and then divide?
No.
Okay.
Wait, I don't understand you. Never mind. Let's the two ratios in this topic is what?
1 to 200,000.
No, the two ratio in this topic. I'm not talking about this particular question. I'm talking about this topic, this concept. The two ratios that you need to know is which two ratio? I'm not talking about this question. I'm talking about this chapter or this topic. The two ratios you need to get out.
The map and the actual, right?
There's one ratio. Map what?
Map.
Map what?
Map ratio.
Map ratio. Map what ratio?
Scale. Ratio.
Yeah, map what ratio? I'm asking for, there are two ratios you need to get out before you can solve this, all the questions here.
The map scale ratio.
What's the first ratio you need to get out?
The
Please.
map scale ratio.
No. Once you get this ratio for the first one and you do something, then you will get the second
Actual
one.
ratio.
If in mathematics, you just have to remember what is the key in this chapter. The key is get the length ratio out.
Oh, length and area ratio.
Yeah. Once you get the length ratio, what you do? You
Times
square.
Square everything.
You square everything to get the area ratio. Does it make sense?
Yeah.
And once you get these two ratios out, just look at the question. Part A. Part A is length ratio because you are given map area, a map distance to actual distance, right?
Mm-hmm.
So I pick the first one. Second one, area, actual area, find map area. You pick one or two?
Two.
Two, because this is about
Area.
right? That's it. That's it. So if you are given this question, you just have to remember this thing. Then you can do all questions already. But of course you need to know how do you get from length ratio to area ratio? How? How?
Find
How do you get from length ratio to area ratio? I have already done it here.
find the length ratio and then square everything.
Yes.
And then find the area ratio.
That's it, yes. You just have to tell me, oh, I just have to square everything for the length ratio to get area ratio. That's it. So basically the concept, the heart of the matter in this chapter is this picture over here. Okay?
Okay.
And then that's it. Continue B and continue to C.
I don't understand.
You don't understand which part?
Like how do you even find the length ratio in the first place?
What's the length ratio given in the question? You need to read the whole question.
1 to 200,000
What's the unit?
cm
Then, what's the unit here?
km in cm squared.
Yes?
Oh, wait.
Actually, your part A, right? You're supposed to give me cm to kilometer already. Part A
Yeah.
is cm to kilometer already.
Yeah.
Huh? What is that? What's part A answer?
416 km.
为什么 Y 20.8 cm is what's that?
416 km.
416 km. 为什么 How? How you get this?
First times 200,000 and then convert to km.
You see? That's your problem. That's your problem. They give you 1 to 200,000 given, and they give 20.8 cm here, right? And they ask you what's the kilometer, right? Does it make sense for you to get this into 1 cm is to how many kilometer first?
2 km.
Yeah, good. So the first step you do is, sorry, let me just tidy this up a little bit. Okay, so 1 to 200,000. Okay, actually the question somehow leads you to think that way. It's not that hard. This is given. This is cm to cm given, right?
Yeah.
So the question says 20.8 cm is to how many kilometer, right?
Yeah.
So in order to get this one, does it make sense for you to find 1 cm is to how many kilometer? For this. Does it make sense?
Yeah.
Why? Why it makes sense? Because if I can find 1 cm is to how many kilometer, then later I just do this to how many kilometer, right?
Yeah.
Using proportionality. But this is the first step. Have you done the first step yet? No.
No.
You try to do it another way. If you do it another way, that is a very bad habit. If you follow your habit or bad habit, you won't get the answers ultimately. Or you will get it sometime, you will get it, you don't get it sometime. I don't trust that. So 1 cm is out to how many kilometer?
2 kilometer.
You sure? No?
Yes.
This is cm. How do you convert to cm?
200,000 divided by 1,000 divided by 100.
Actually, it's divided by 100 first.
Divide
So
by
they get
100.
meter. Then you divide by 1,000. Then you get, so it's 2 kilometer, right? right?
Wait, no, not divide by 100 first. Because it's cm.
cm, you divide by 100 is meter, right?
Yeah.
So you divide by 1000, you will get kilometer, right?
Yeah.
So that's why you have to write this down to help you. If you cannot digest it using your brain, it's okay. Write that down. If you write that down, you will not make mistake. Come on. If you don't write it down, you try to use your brain, and you know we cannot trust our brain. Our brain is actually very tiny, okay? Our brain mass is actually very tiny. So you are supposed to divide by 100 first, then after divide by 1000. And then what's the...
2 km.
Yes. That's how you get 2 kilometer. So once you get this, 1 cm to 2 kilometer, it's very clear cut, right? How do you get this from this?
6 km.
So it's times.
Times 20.8.
So this side also must.
20 times 0.8. 41.6.
Yes. That's how you get 41.6. I don't want you to get it any other way, except you do it this way. So this is the length ratio. Right? Which one is the length ratio, by the way? You have this one. You also have this one. Which one is the length ratio? This one or this one?
The first one.
The first one is the length ratio. How do you get to area ratio then? Square.
Square everything.
So 1 square, cm square, 2 square, kilometer square. So tidy it up, 1 cm square, 2, 4 kilometer square. So this is the area ratio. Right? So once you have this, what the question gives you? It gives you 9.4, right?
Yeah.
So you put the 9.4 here or here?
4 km.
Yeah. Then you ask yourself, how do you get from 4 to 9.4? Times.
Times 2.35.
2 point?
2.35.
Very good. So over here also must times 2.35. Right? So therefore it's 2.35 cm square. That's the answer. Right?
Yep.
Like I say, the part C is a bit implicit. Okay? Implicit. Not openly inform you. So the field is represented on the map by a square of side. So basically, if you try to sketch it, right? A square of side 1.6. What's the meaning of that?
That means a square and the side is 1.6.
Yeah. So in a way, they give you the area already. In a way, this statement is for you to find the area. 1.6 what? Cm. So what is the area? So it's 1.6 square, right?
Yeah.
Which is
1.6 square. 2.56.
2.56 square. Cm square, right?
Yeah.
So your 2.56 cm square, you put it on here, on the left, or you put it on the right?
Left.
Left. Okay, good. So just erase this. 2.56 cm. So the question mark will be this one. So I hope you see this one is times 2.56, right?
Yeah.
So similarly, this one is also
10.24.
exactly. Okay. So the gist of this topic is
Just remember the length ratio and
Uh-huh.
the area ratio.
yeah. Just remember length ratio and the area ratio. And how do you get the length ratio to the area ratio? You square everything in the length ratio. Right?
Yeah.
So of course, if you are given the length ratio, you can get the area ratio by square everything, right?
Yeah.
Then what if I give you the area ratio instead? I ask you to give me the...
Divide.
What's the opposite of square?
Oh, square root.
Yeah. You have answered yourself. So this is the area ratio, right? I hope you can tell this is the area ratio. How to tell?
The
Square.
square.
Yes. So how do you get the length ratio?
Square 5.
Huh? Area ratio given here. You still want to square it to get length ratio?
No.
Just now is square to get area ratio, right? So what's the opposite of
like
square?
Square root.
Yes. So you square root everything.
I cannot convert this into anything.
Later. You square root everything first. So you square root get square root 5 cm, right?
Yeah.
To square root 10 kilometer square, right?
Yeah.
Just do it this way lah. If they give you, hey, 1 cm to how many kilometer? Oh, the square should be gone, huh? Square root already. So ask yourself, how do you get this to here? You divide by square root 5, right?
Yeah.
So same thing, you divide by
Divide by square root 10.
square root 5. So what's the answer?
Oh. I still cannot convert it.
Never mind. Is it a mixed number?
No.
Then 3 significant figure. That's your last result.
1.41.
1.41. Okay, good. Done. Okay? That's how you do it. The reverse of square is?
Square root.
Okay, good. So what if they give you this? So length ratio, you square the length ratio, you get area ratio, right?
Yeah.
And by the way, when you square everything. You square everything in the length ratio, right?
Yeah.
How do you get the length ratio to volume ratio? What do you think?
Cube.
Yes.
Cube everything.
Length ratio to area ratio is square. A square. Length ratio to volume ratio is cube everything. So therefore, from here to here is square. So what if from area ratio back to length ratio? Square root.
Okay.
Right?
Yeah.
Here to here is square, right? The reverse of it is square root. If you want me to go back, right?
Yeah.
Then therefore, if you want me to go back from volume ratio to length ratio, since it's cube, so it's cube root. Does it make sense?
Yeah.
Does it make sense?
Yes.
Yes. So that is how you can solve this kind of question. Very simple. Okay. So I'm going to give you a summary of what we have learned so far. They are new topic, but they are not very new. They are just like so intuitive. Right? Intuitive means it makes sense. It just makes sense, right? Not rocket science. So the first thing we do is the Pythagoras theorem, which the River Valley student they have learned already. So Pythagoras theorem.
Pythagoras theorem is
The
taught,
a square
next
plus
year.
b square equals to c square. Yes.
It's taught next year during term 1 term 2.
Yeah. But like I said, the River Valley student they have learned it already.
Okay.
So Pythagoras theorem, we have learned it already. So for Pythagoras theorem, the most important thing is this is for right angle triangle only,
Yeah.
not other triangles. And by the way, C is the longer side, right?
Yeah.
And then the A and B, it doesn't matter. Okay?
Yeah.
So the first thing. Then the second new idea we learn is the similar figure. Actually, similar figures, right, is triangles or quadrilateral triangle, quadrilaterals, yeah, which is four-sided. Okay, but we mainly use triangles to illustrate. Okay, what I want to tell you is, let's say they say this triangle is similar to this triangle. You know what it means?
That means like
That means
this one is something times more
this
than
side,
this one.
yes, this side, it times a factor to get this side. Similarly,
The other sides are
this
also
side,
the same.
yes, also times the same factor to get to that.
And then the
Of course, the
C
last
is
one
also
is the same thing.
something.
Yeah. So this one is the same thing. So maybe I use a different color. So the factor for the yellow ones and for the black ones, for the red one, has to be the same.
Okay.
Okay, in order to have similar figures. Okay, if they are not similar, then yes, different. They are all different.
Right.
Okay, so that is one thing. The other idea for similar figure is this angle is equal to this angle, and then this angle is equal to this angle, and then of course the last angle here, is equal to this angle. And do you know why I need to get the two figures out? So that you can match accordingly. If I don't, so basically you need to get the two figures out in the same orientation. Okay, what if they are not in the same orientation? Let's say I give you this. Let's say this.
Then flip one of them.
Yes, you can either bring this, rotate this. Why? Because once you rotate it,
Then it's easier to.
then it's easier for you to match, right?
Yeah.
Then you can see which one match which one. So once you can match already, if they are similar, then they times the same factor to get to that.
Yeah.
Okay? If small to big, if you are not given the small one, let's say you give the big one, let's say it's 15. Okay?
Yeah.
So big to small is divide lah. Does it make sense?
Yeah.
So let's say I give you this is 15, this is 5. So in a way,
Divided by 5.
yeah. So basically you can get actually is times 3. It really depends how you look at it. From the small to big is times 3. From big to small is divided by 3. So it really depends how you look at it. For similar figures. Okay?
Yeah.
So for similar figure, the first step you need to do is you need to get them in the same orientation. Because in the same orientation is easier for you to see. If they are not in the same orientation, you need to turn your head here and there is very hard, right?
Yeah.
Then of course the last concept we learned today is actually map to real life, right?
Yeah.
Or actually this concept here, right, is very similar to just now this one. Why? Let me explain to you. Just now you say this side it match with this side, right?
Yeah.
And then there is a factor which is times 3, right, for you to go from here to here, right? Same thing. Therefore, if this is 2, it has to times 3 to get 6 here, right? Does it make sense?
Yeah.
Yeah. So therefore, the idea in the map to real life is if they give you map is 1 cm to 3 km, right?
Yeah.
Then now they give you, hey, my real life is actually 4 km. So how do you get to cm? Just find out. Proportionality. How do you get to here? Is you times 4/3, right?
Yeah.
So therefore here also must times 4/3. Then you will get 1 and 1/3. Alright? So this is your length ratio, right?
Yeah.
So you square it to get.
Square to get area.
Yes.
ratio.
So you square everything. So 1 square cm square to 3 square kilo square. Right? So it's 1 cm square to 9 kilometer square. So in this case, they will tell you either the map area or they will give you the actual area. Then you find the other one. So let's say they give you this is 2.5 kilometer square. So what is the map? Ask yourself, how do you get this? Right? So you just use 9 divided by this.
But that's area also.
Yeah. So you just divide by same thing to get the question mark.
Okay.
Yeah?
Yeah.
Yeah. So these 3 concepts. No, I don't think they are rocket science. Okay, they are not rocket science. Very, very simple. Just have to follow. For the map to real life problems, length ratio, area ratio. How do you get from length ratio to area ratio? Square the length ratio, everything, right?
Yeah.
Okay, good. So actually, then I want to touch the other. Actually, it's a advanced version of prism.
There's another type of prism.
No. So there is no another type of prism. So basically, you have the triangular prism, right?
Yeah.
So you can also flip it the other way lah, which is your question lah. Huh? So this is prism. Then you have the trapezium prism. Okay, so how do you get the volume of prism? Is depends which area is which is the base area.
Base area is like
So
the
you
triangle.
so in this case it's the triangle. And then how you cut? You cut this way, right? 1, 2, 3, 4, 5, 6 until the end. So therefore this is the height. Okay?
Yeah.
So for this one the base area is this one, right?
Yeah.
How do you cut? You cut it this way,
Cut
right?
like that.
Right? You cut it this way, right? So you continue to cut. So therefore this is the height lah. Right?
Yeah.
So for your that question, something like this, I guess. Yeah, something like this. Right?
Yeah.
So which one is the base area? This one lah. Right?
Those two. Wait, no, yeah, only that one.
Yeah, this one, right?
Yeah.
Then how do you cut? You cut it this way, right? So this is the height.
Yeah.
Okay? So for the volume of prism is base area times the height. Or sometimes they use cross-sectional. So this is just another term, a cross-sectional area times height to get the volume. Okay? So I am going to so we consider so basically prism is we consider this solids. So solids you have prism, then you also have the cuboid. Yeah, cuboid, this one. Okay? So you also have the cube, right? Right?
Yeah.
Then you also have the cylinder, right? Did they test you cylinder this time around? No, right?
No.
Oh, okay, never mind. So cylinder is also one type of solids. Okay, cylinder is something
Just cut
something like
down
this.
from, like,
Something
the
like this.
circle.
You're talking about how to find volume of this?
No, like the height.
No, you're talking about how to find the volume of this or what?
Like cut down from the circle.
Yeah, so you cut this, then you continue. So basically this is the height lah.
Okay.
So this is the base area, right, which is the circle, right?
Yeah.
Okay, but we are not talking about this four. I'm going to talk about more solids. I think you know the famous one of the wonders is pyramid, right?
Yeah.
Pyramid. So the pyramid is okay. In order not to spoil the image of pyramid, so I better get it from online. Pyramid, okay, good, nice. Oh, they have something as pyramid. Yeah, something like this, but I want to get a so we have. So how do we find the area and the volume of pyramid? Okay. Okay. So what do you see for the pyramid? I hope you see triangles. How many triangles you see? One, 2, 3, 4, right?
Yeah.
So basically you see 4 triangles,
4 triangle and a square.
which is the base, right?
Yeah.
Yeah. Over here maybe it's a square, maybe it's a rectangle. So depends, right? So either a rectangle or square, right? So if you want to find the surface area, very simple lah. Just 4 times area of the one triangle, right? Then plus either the rectangle or the square. So that's for the surface area. Yep, yes. So this is the surface area, very simple. Okay, just divide and conquer. Okay, so now the volume. How do you find volume? Right. So the volume for this is there is a formula for it. Okay, so the formula, I'm not sure if the formula is given for pyramid, but most likely I think no, they don't give you the formula. So we have to get the formula out for them. So this is the formula. So let's get it out. So the volume formula you just like memorize like, it's just like what is the formula for triangle, half area of triangle, half times base times height, right?
Yeah.
So same thing like over here is V volume is equal to L times WH divided by 3. So of course we didn't know what is LWH.
What is W?
Yeah, so let's look at it. one by one. Oh, looks like W actually is the width. Which is the width.
Oh.
Okay? Let's look at it one by one.
Base length.
So, yeah, so W actually is the base width. Does it make sense? Here, ma?
Yeah.
Then L is actually the length of the base. Okay?
Okay.
So it's quite easy, base length. Okay? H is actually the height. Quite okay. So it's the height. So far so good, right?
Yeah.
So, oh, then you can actually see this as 1/3 of a cuboid.
Oh.
Why? Because the cuboid is what?
Cuboid is
Length times breadth times height, right?
Right.
But can you see over here is divided by
it's like that
3.
one, but divided
So it's divided by 3. So every pyramid
is one
somehow
third
is
of
1/3
one
of a cuboid. So you have memorized. I mean, I also have memorized already for the volume, right?
Okay.
But now, life is not always so simple. I think usually they will give you this one, which is, let's say they give you this is 20. Then they give you the breadth is 10. Now the funny thing is, they might not give you the height. They might want you to find the height
Oh.
by giving you, okay,
Absolutely.
this is the height of the pyramid, right? Do I have this? Okay, never mind. I can make use of this.
So how are you gonna find the height of a pyramid with just 20 and 10?
I'm going to tell you. Okay, so usually they will give you this one. So this is the height of the. This height is the height of what?
Height of the triangle.
Yes. So this is the height of the triangle. So given the height of the triangle, which is here, okay, I'm going to use different color. We are not doing rocket science also. So I hope you start to see something. If this is the height of the triangle, so I'm going to get it out. So you have the height of the triangle, and then you have the height of the pyramid. Can't you see you have this side? What's the length of this side? Can you make a guess?
Which side?
This one.
Oh, from the side
From
to
this
the middle.
to the middle is. This whole
10
thing is 10.
divided by 2.
Yes, so it's 5.
5.
So this is 5, right? So if you are given the height of the triangle, which is, let's say, I don't know, maybe 16.
Plus B squared.
Yes. So you can find the height of the pyramid. So there are 2 heights here which you need to pay attention to. Right? So in this case, which one is the longer side? 16 is the longer side, right?
Yep.
So you can make use of that, lor.
16
So it's 16 square minus 5 square, then you get the b square.
251 square is something I cannot.
Never mind. So you just square root it, right? So you square root the 231. So can you give me 3 significant figure?
15.2.
Yeah. So next time when you get the answer, you get it into mixed number first. If you cannot get it in the mixed number, then it's 3 significant figure. Except for dollars. Okay? So that's the cm. Oh, then can already. So the height is 15.2, the width is 10, the length is 20. Then you just put it in, then divide by 3. Right? So you get the volume of the pyramid already. Right? Yeah. It's okay. So I focus on the approach.
Yeah.
Okay? So we have done pyramid. Okay? So life is not so simple, right? It's like so basically besides this prism, cube, and this cylinder, today we learn a new one, pyramid. So pyramid is 1/3 of cuboid for volume. Does it make sense?
Yeah.
Yeah. And how do you find the height of the pyramid? Make use of the Pythagoras theorem, which of course you need to draw it out lah. Okay?
Okay.
Draw it out to see how to do it. Okay? Now, another type of solid is the ice cream cone. So I also don't want to spoil the image of ice cream cone. So I just want to ice cream cone.
So just write cone.
Yes. No, I want it to be. I want to take a cute, very cute picture.
So what?
Also, so you want a cone? Okay, never mind. So I want to get the.
No, because they're not going to show you like a very cute cone. They'll just
To me,
literally
I
show
think
you
this is
ice
okay
cream.
lah. This is okay. This one is quite okay. Okay, good. Okay, so yes, okay lah. So time to take a break. Okay, before we talk about this code.
Joe, did you know my brother